this make sense? Do you have any question? Perfect. So I want to give you another example. So in this equation, you want to determine the limiting reactant. Problem is giving you mass of the two reactants, which is aluminum, mass of aluminum, and mass of ethylene oxide. These two reactants react together to produce aluminum oxide and iron. And this reaction produces so much heat that is used when in a war, you want to destroy your weapons, even a tank. If you want to destroy a tank, so it doesn't get into the enemy's hand and you're pulling back, you use this reaction to melt the whole tank in a war. It produces a lot of heat. So the question is, how much product do you make? If you are using 124 grams of aluminum and 601 grams of iron oxide. Although you see iron oxide 601 is larger than 124, but you can't answer the question based number of grams. We answer questions based on determining the limiting factor. How do we determining the limiting reactant? By looking at number of moles, not number of grams. That means I have to convert one of these number of grams into moles, look at the equation, calculate number of moles of the other reactant, and see which one is excess. The one which is not in excess, the one which is we are short of, that makes limiting reactant. That is going to determine amount of the product. Are you with me so far? Are you with me? Before I do the problem, I want to see if you follow up the logic that I'm using. Stop me and ask a question if you're not clear so far. All right, perfect. Let me go. Next step. So I mass, does it make sense that I choose one of these to either aluminum, grams of aluminum, convert it to number of moles of Al, convert it to number of moles of Fe2O3, convert number of moles of Fe2O3 to grams, and see if Fe2O3 is excess or is it short of. That's what I'm going to do. I can start with grams of aluminum. We solve chemistry problem in terms of moles of reactant. If I have moles of one reactant, I can use the coefficient between reacting substances to determine number of moles of the other one. Once I have number of moles of Fe2O3, I can go to the grams and see how much I need Fe2O3. Now the problem is giving me amount of the Fe2O3 used, but it could be excess or it could be short of. Then I decide which one we are short of. That would be our limiting reagent, and my calculation would be based on limiting reagent, not the reagent which is excess. So I have grams of Fe2O3. Let's suppose another option. Another option is to start with the grams of FeO3. I can go to moles of FeO3. From that, I can determine moles of aluminum and go to grams of aluminum to see if we have enough aluminum or not. In other words, it doesn't matter. You have two options. You choose the way you want. Use grams of one of the reactant given, determine amount of the other reactant needed. Either one will give you the same result. So let's start, oops, wrong direction. Let's start with grams of Al. So I have to convert grams of Al to moles of Al. Can I write grams of Al on the bottom, moles of Al on the top? The relationship between top and bottom is 1 mole of Al is 27 grams. Does this make sense so far? So I'm canceling grams of Al, going to moles of Al. Next, I need a conversion factor to cancel moles of Al, to cancel this and go to moles of FeO3. Would this work? Where I can cancel moles of Al. Let me clear these a little bit. There's too many things. They confuse you. So I cancel grams of Al. I go to moles of Al. I cancel moles of Al. I go to moles of Fe2O3. Can you guess what I should do next? What conversion do I need next? Anybody? Make a suggestion. What should I do next?
Fe2O3 to its grams.
Excellent. Thank you, Victoria. So do I write moles of Fe2O3 on the bottom to cancel these two? And write grams of 1 mole of Fe2O3. That's molar mass of Fe2O3. So now I have canceled everything. The answer is giving me grams of iron 3 oxide if you use your calculator, and you're canceling again one more time. Let's see how conversion is canceling 1 unit at a time to get to grams of Fe2O3. So grams of Al and grams of Al are canceling. Moles of Al from the top is canceled by moles of Al on the bottom. Moles of Fe2O3 is being canceled with the moles of Fe2O3, and amount of the product, which is iron of Fe2O3, 367. So what is this telling you guys? Amount of aluminum which we are given needs 367 FeO3. By looking at the problem, which one of these two reagents are limiting reagent? Which one we are short of? Which one we have too much?
The aluminum.
Excellent. Thank you. Good job. So we have excess Fe2O3. Yes. That means we don't have enough aluminum. That is limiting reagent. So if I want to solve this problem, I have to base my calculation on amount of Al. So now I know what to do. To start with 125 grams Al and calculate how much Fe2O3 you're going to produce. So we have more, excuse me, we have more Fe2O3 than we need. That's excess. The other one, which we don't have enough, is limiting reagent. So now I can go back, do calculation, basing my calculation on something which is really determining the factor. Good job, Leah.
Thank you.
So grams of Al. Given by the problem, I can go to moles of Al. Once I have moles of Al, I use the stoichiometric coefficient. That means balancing coefficient in the equation. So I can calculate moles of aluminum oxide. And once I have moles of aluminum oxide, I can determine grams of aluminum oxide. Does anybody have any question? How do I do any of these conversions? Just let me know.
So just to clarify real quick, you first pick a reactant and figure out how many moles it has, and then with that amount of moles, you figure out how much of the other reactant it would make. Correct. To figure out the limiting reagent. Right?
Absolutely, Bella. See, we have two reactants, right? So we have to see which one we are short of. That is limiting reagent. That determines amount of the product. Just like the example I gave you, the reactants are number of boys and girls, and product is number of dancing, maximum number of dancing couple. So can I say, I first have to count number of boys, then number of gays, girls, see which one we are short of, then maximum number of dancing couple is based on the girls, not boys. The same thing here, 2 reactants, determine number of moles, use the stoichiometric coefficient, which are balancing coefficient in the equation. Then decide which one is excess, let that go based on your calculation on the one which is we are short of, which is number of girls. Doesn't matter, you have 50 boys or 100 boys or 2,000 boys. Maximum number of dancing couple is decided by number of girls because those are limiting factors. Does this make sense?
Yeah, that makes sense. And then you always have to convert it to moles beforehand.
Yes.
Okay.
Right. Exactly. We solve chemistry problems in terms of moles, not in terms of grams. Another word, if I ask you what is maximum number of dancing couple, you don't look at how much each person, boys and girls, how much they weigh. The weight doesn't matter. Some of them could weigh 250 pounds and some of them could weigh 120 pounds. It doesn't matter. It's number of the boys and girls which decide number of dancing couples. So mass must always be converted to number of moles because equations show the ratio between number of moles of reacting substances and number of moles of product, not number of grams.
Okay, that makes sense. Thank you.
Thank you for asking. I bet there were other students who had the same question and you helped them to understand. Thank you for helping others. All right, so can I say I'm starting with 124 AL? That's based on my calculation, limiting reagent. I can cancel grams to go number of moles, and I can cancel number of moles of AL, go to number of moles of the product. Problem was asking how much AL2O3 you make. Once I have number of moles of the product, I can always convert it to grams. And if you check your conversion factor, do you see grams of AL and grams of AL cancel each other? Why am I doing this? I want to make sure I have used the right conversion factor. I want to make sure the unit which is left is unit of the substance that problem is asking. Let's see if we use the right conversion factor. So grams of AL and grams of AL cancel each other. Moles of AL and moles of AL cancel each other. Moles of Al2O3 and moles of Al2O3 cancel each other. So I'm left with grams of Al2O3. Problem, I'll go back to the problem. Problem is asking how much Al2O3 you're going to make. And I got the right unit for mass, 234 grams of what problem is asking. That means you did right conversion factor. Any question, guys? Do you see how I'm trying to help you to do one step at a time? Guys, in life, you always have a problem. You always want to go to a solution. If you develop this ability to break down a complicated problem to one step at a time, make a decision for each step, you certainly meet your goal. Otherwise, if you don't do this analysis, you can get confused. It's hard to come up with the right solution. So it's not about chemistry. It's not about physics. It's not about calculation. It's about your success for the rest of your life. How to take a complicated problem, break it down to small steps, and do one step at a time to reach where you want to reach.